Assalamu alaikum. Hello students. Today we gonna start a series of problem solving of electrodynamics by David J. Griffiths, 4th edition. We are going to start example number 2.1. The statement is find the electric field a distance z above the midpoint between two equal charges a distance d apart. That means we have to find the electric field at some point P, which is at a distance z from the midpoint of the line joining these two similar charges. We have to find the net electric field at this point P due to both of these two charges. Remember, these two charges are similar. They have equal magnitudes and same signs. Either both of them are negative or both of them are positive. Suppose here we consider that both of them are positive charges. Both of them are positive charges. Okay. Now, one thing more. What is the distance of this point P from these two individual charges? Suppose, let's say that distance is named as R. This distance is R and this distance is also R because the point P is at the same distance from both of these two charges. Okay. Now, what is the electric field at this point P due to individual charges? Suppose the electric field at point P due to this charge is in this direction and named as E1. Similarly, the electric field at point P due to this charge is in this direction and that is named as E2 because the electric field due to first charge, that will be named as E1 and the electric field due to second charge will be named as E2. Okay. Now, if we resolve both of these two vectors, if we resolve the vector E1 and E2 into their components, the x component of this E1 vector will be in this direction and will be named as E1x, and the other component will definitely be directly upward and will be named as E1y because it is in the y direction. Now, if we resolve E2 vector, then E2 vector, the x component of E2 vector will be in this direction and named as E2x, and its y component will be directly upward and will be named as E2y. Okay. Now it's very clear that the x components due to individual fields are opposite to each other and definitely will be equal in magnitude. Why they are equal in magnitude? Because both of these two charges have similar signs, so both of them will produce the same magnitude of the field. Okay, and this point, this is the central point, and this point is at the same distance from both of these two charges. That's why the x component, that's why the electric field, the x component of electric field at this central point due to individual charges will have same magnitudes and clearly opposite to each other, so will cancel out and we are left with only with y components. That means that the net electric field at point P will be directly upward. So the net electric field at point P will be directly upward because the net electric field at point P is only due to y components. So if we discuss the net electric field at point P, we can write here the electric field at point P will be equal to the y component of first electric field plus y component of second electric field. Okay. Now what is the y component? What is the y component of the first electric field and what is the y component of the second electric field? Listen carefully. We are well aware that we did not define the angle here. This angle is named as theta. This angle is also named as theta. It is not restriction that you just have to take this angle as theta. You can also use these angles, this one and this one. It's your own choice. Here I'm using these angles. Okay, now listen carefully, that the component of our vector directly opposite to our angle is defined with sine theta, while the other component is defined with cos theta. Now here the x component would be defined with sine theta, and the y component will be defined with cos theta. That's why E1y will be written as E1 cos theta, and similarly E2y will be written as E2 cos theta. Okay, and further it can be written as 2e cos theta. Why? Because the individual electric fields are equal in magnitude. The individual electric fields are equal in magnitude, and I've just explained the reason. Okay, the individual electric fields are equal in magnitude, and let's say this is named as E. Okay, that's why if we sum up these two quantities, we get 2e cos theta. Now E, what is E? Here E is electric field produced due to point charge. That's why we can use here the formula of the point charge, that is kq by r square. Kq by r square. And what is r here in this formula? We are aware that the r is the distance of our required point from our charge. Okay, but unfortunately in the statement of this example, this r has not been defined. Here we have introduced r ourselves for just our simplicity. So that's why we have to convert this r into non-variables. And how can we convert this r into non-variables? You can see here, this is a right triangle. This one is a right triangle. As this is a right triangle, so according to Pythagoras theorem, this one would be the hypotenuse, because we are well aware that the side of our right triangle opposite to 90 degree will be defined as hypotenuse, and the side directly connected with our angle is named as base, and the side directly opposite to our angle is named as perpendicular. Okay, so according to Pythagoras theorem, this r square will be equal to d by 2 square, because this complete distance is d. This complete distance is named as d. So half of that distance will be d by 2. Okay, so r square will be equal to d by 2 whole square plus z square. That's why in the next step I can write here what? 2kq, and I can replace r square by z square plus d by 2 square. Okay, and what is cos theta? Again, look here, cos theta by definition is base by hypotenuse. We are well aware. What is the base here in this case? Here in this case, I've just told you that the side adjacent to our angle is named as base. So here base is z, and the hypotenuse is r. So I can write here z by r. And again, what would be the r? According to Pythagoras theorem, this r will be equal to square root of z square plus d by 2 square. Okay, you can see here in this triangle. You can see here in this triangle that r square will be equal to r will be equal to inside the square root d by 2 whole square plus z square. Okay, so here I can replace this cos theta by its value. So I can write here z divided by z square plus d by 2 whole square inside the square root. And what does the square root mean? It means whole power 1 by 2. Okay, now in the next step it becomes what? 2kqz divided by z square plus d square by 4 whole power 3 by 2, and this is the net electric field at our point P due to these two charges. Okay. Now let's discuss a special case. What would happen if this distance z becomes what would happen if this distance z would become very greater than this distance d. Okay, I'm repeating the question, that what would happen if this distance z becomes very greater than this distance d. Let's solve for that special case. So in that case definitely if z is very greater than d, then definitely this z square plus d square by 4 will approximately be equal to z square. Z square plus d square by 4 will approximately be equal to z square. Okay, so this equation number 1 now becomes what? Electric field at point P will be equal to what? 2kz divided by 2kqz divided by this quantity will be replaced by z square, and the power 3 by 2 will be written as it is, z square whole power 3 by 2, and in the next step it becomes 2kqz divided by z cube, which becomes in the next step as k2q divided by z square. Now look here, what does it becomes? What does this mathematical expression represents? It represents that the collection of our, now listen carefully, this mathematical expression actually this expression is for the electric field of a point charge. We know the electric field due to point charges, kq divided by distance square, whatever the distance is. Here same is the expression, k multiplied by charge divided by distance square. That's why this mathematical expression represents that whenever the distance z becomes very greater than the distance between the charges, then in that case our composition of these point charges will behave like a point charge. Okay, the collection of our these two charges will behave like a point charge for very larger distances. Hope you understand. See you again in the next lecture. Bye.